In this module, you will learn about motion and the types of motion. In everyday life, you see some objects at rest and others in motion. Birds fly, horses gallop, water flows through rivers, and cars move. You say these are in motion. Thus, motion is a state of an object in which there is a change in its position with respect to its surroundings. When a car race starts, the position of each car participating in the race changes relative to the stands and spectators. This is because the cars are in a state of motion. What happens when we compare the state of two or more than two objects? For instance, let us consider the state of a car driver. It is difficult to answer this question. This is because, with respect to the car, the driver is at rest, but with respect to the other things around, he is in motion. Thus, the states of rest and motion of bodies are relative. Consider a bus moving along a road. A passenger in the bus perceives the trees and other objects outside the bus to be moving, while his co-passengers seem to be at rest. Motion of objects or bodies can be along a straight line, called linear motion, circular motion, vibratory motion, or a combination of two or more of the above three types of motion. Linear motion involves an object moving along a straight line. For example, cars moving along the straight path in the circuit exhibit linear motion. In case of circular motion, an object moves along a circular path, like the motions of a merry-go-round or a giant wheel. In case of vibratory motion, an object moves to and fro from a fixed position. The motion of the needle of a sewing machine at work is an example of this type of motion. In general, we encounter many examples in our daily life where there are combinations of different types of motion. For example, when a bicycle moves, the motion of the frame of the bicycle is along a straight line, whereas the wheels of the bicycle rotate about their axle. We learn that motion and rest are relative. When an object moves, its position changes with time. To locate the position of an object, we take a reference point. For example, if your school is situated 5 kilometers east from your home, the reference point considered is your home. This reference point becomes the origin. Similarly, when you say the park is situated 2 kilometers east from your home once again becomes the origin. Selection of origin is taken as per convenience. For example, with regard to the distance of your school, if you take the park as the origin, then you can say that your school is 3 kilometers east of the park. Suppose you decide to walk to school from home and back. Here the origin is your home. The initial position and final position is the same, which is your home. In this case, the total length of the path travelled by you is the sum of the length of the path from your home to school, which is 5 kilometers, and the length of the path from school to back home, which is again 5 kilometers. The length of the path travelled is called the distance. In the example we considered, the distance travelled is the sum of 5 kilometers from home to school and 5 kilometers from school to home, which is 10 kilometers. When describing the distance travelled by an object, its direction need not be specified. The numerical value along with the unit to be specified is called magnitude. Consider another case, where you travel from home to school and while returning, you decide to stop at the park. Here, origin is your home and the distance travelled is the sum of the length of the path from your home to school and school to park. Hence, the total distance travelled is the sum of 5 and 3 kilometers, which is 8 kilometers. The decision to go to the park changed the position from home to the park by 2 kilometers towards east. Here, in order to know the change in position, we need to specify the direction along with its magnitude. Change in position is called displacement. Let's analyze both these qualities, taking an example. At the end of her school day, Mary goes from the school to the playground. The school is 3 kilometers away from her home and the playground is 4 kilometers away from the school. From home to school to the playground, Mary travels a total of 7 kilometers. This is the distance travelled by Mary. Thus, distance is the actual length of the path covered by a moving object, irrespective of the direction of motion. However, the straight route from Mary's home to the playground is only 5 kilometers long. Therefore, Mary's displacement from home to the playground is 5 kilometers, as against the distance covered by Mary in reaching the playground, which was 7 kilometers. Thus, displacement is the shortest distance between 2 points, irrespective of the path between the points. When an object is in motion, its motion may or may not be regular all through its journey until it comes to rest again. Let us observe the yellow car in the race. The car moves 50 meters every second continuously. Thus, for each second, if we note down how far the car has moved from the starting line, we see that the displacement during any 2 consecutive seconds is the same. This car is in uniform motion. An object is said to be in uniform motion if it shows equal displacement in equal intervals of time, however small these intervals may be. Let us observe the red car in the race and record how far it has moved from the starting line for each second of motion. We see that its displacement during any 2 consecutive seconds is not the same. This is non-uniform motion. An object is said to be in non-uniform motion if it travels unequal distances in equal intervals of time or equal distances in unequal intervals of time. In this module, you will learn about motion and the types of motion.